So hello guys, very good afternoon. This is Sanjay Rathi. Precision rectifier is important topic from analog electronics. It is also known as what active rectifier. And here we are going to use what operational amplifier. Means it is application of operational amplifier. Okay. First of all, we will discuss what are the limitations of passive rectifier like half-wave rectifier, bridge rectifier, center tapped transformer type. And then we will connect operational amplifier and we will design precision rectifier, guys. So this is a precision rectifier. Then this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam and I have trained more than 1 lakh students for different competitive exams, guys. Right now, this is my channel Electronics by Sanjay Rathi. If you want PDF, notes, important questions, latest information about the exam, then you can join. Now, this is rectifier, right? Already we have discussed what all the rectifiers, basic block diagrams of regulated power supply, that is the transformer, rectifier, filter. And in coming session, we will get the idea about the regulator also, right? Then load. So already we have discussed what a half-wave rectifier, full-wave rectifier, center tapped transformer type, a bridge rectifier. Okay, so very good evening. Now, what are the limitations of these rectifiers? First of all, we will discuss this point. Then, what is the precision rectifier? Okay, very important topic for GATE examination as well as other competitive exam. So, what is the precision rectifier? I am going to discuss here. Give me 1 minute. Yes, please. First, simple passive rectifier. What are the limitations of those passive rectifier, guys? For example, this is the half-wave rectifier, RL. Right? Now, here we are giving the input and here we are getting the half wave, right? Suppose, okay, good. Okay, तो तो हो गया ना एक बार. तो जब when we are giving the competitive exams, then it will boost your what confidence. Yes, यहाँ से बाहर कहाँ जाएगा question? देखो, if you are assuming the ideal diode, suppose I am giving the signal. What is the signal here? That Vi is equal to Vm sin omega t. Right? For example, it is a Vm sin omega t. Then this is the 10 sine of omega t. If you are assuming the ideal diode, then what is the DC level at the output? The DC level at the output is Vm by pi. Yes, DC level at the output is Vm by pi. DC level at the output is Vm by pi. You can say 10 by pi. Right? 10 by pi. Yes, that is the answer, 10 by pi. But what is the unit here? I have not mentioned the unit of the input signal. I have not mentioned the unit of the input signal and I am assuming the ideal diode. For ideal diode, the characteristics will start from this point. For half-wave rectifier, the characteristics already I have discussed. Characteristics will start from this point. Up to this point it is 0 and after that this is the case. Okay, this is the V0 versus Vi. And simply we have when the Vi is greater than 0, diode is on. When the Vi is less than 0, diode is off. Right? And that is the case. Now, we are getting the DC value 10 by pi here. But This is applicable for what? Volt. If suppose the unit here is millivolt, so the unit is here only millivolt. Now what is the highest value here? Highest value is only 10 millivolt. Highest value of the input signal is only 10 millivolt. Now what is the drop across the diode? Actually in a practical diode, the drop across the diode is what? 0.7 volt. Drop across the diode is 0.7 volt. Right? For example, this is the diode. Under practical condition for silicon diode, what is the drop across the diode? 0.7 volt. Means minimum 0.7 volt is required to make this diode forward bias. But what is the highest value here? Only 10 millivolt. So guys, tell me, in that case, we have to consider the ideal diode or practical diode when the input signal is very, very small. This is a small input signal. No doubt, when we are giving the very large input signal, for example, it is in volt. So this is the highest value is 10 volt, and then we can say, okay, in comparison to 10 volt, that 0.7 volt is negligible as compared to 10 volt. It is a large signal. Right? And we are assuming ideal diode. We are just neglecting the drop across the diode. But suppose the input signal is in range of millivolt. Highest value is only 10 millivolt. So when we are applying the highest voltage here, and what is the highest value? 10 millivolt. Tell me guys, this diode is on? No. For full range of the input, the diode will remain off. Right? And what is the output? 0. If suppose we are applying this signal here, then for full range of the input, diode will remain off, and that is the wrong answer. So what is the DC value? 0. Why? Because it is in the range of millivolt. The diode will never conduct. And we have to consider what? Practical diode. In that case, we have to consider the practical diode. Okay, we will discuss. Okay. Please send me on WhatsApp. I will give the answer for those. Hai na? Then, now focus on this. This is an important topic. If you find any difficulty, then please inform me. The precision rectifier. What is the use of the precision rectifier? First of all, try to understand this is a passive rectifier, normal rectifier. If you are giving the large signal that is in the range of volt, okay, it will work, and that is the ideal characteristics, and you can neglect the drop across the diode. You can consider the ideal condition, you can consider the practical condition, both possible if the input signal is large. But when we are considering the input signal small, this is called small signal, then you have to consider the diode what? Practical diode. You have to consider the practical diode. Now when we are considering the practical diode, then what is the minimum drop required here? 0.7 volt. Okay. Now because the signal is very, very small, that's why the diode will never conduct and output is 0. So what is the problem with this rectifier? What is the problem with this rectifier? Simple. The problem with this rectifier is क्या rectifier के साथ? What is the characteristics is start from what? 0.7 or cut-in voltage. Characteristics start from cut-in voltage. Up to this point 0. Then after that, this is the line. If the input signal is less than the V gamma, diode will not conduct, and after that diode will conduct. Okay. So this is the characteristics of this diode, and this is the characteristics of this rectifier, V naught versus Vi. Right. Now, if you want to rectify very, very small signal like it is in the range of what? Millivolt, then the characteristics should start from what? Characteristics should start from this point. Just like what? Ideal rectifier. Start from this 0 point. Just like what? Ideal rectifier. So this is the transfer curve or the characteristic curve for what? Precision rectifier. Precision rectifier. And this is for this particular diagram, passive rectifier, normal rectifier. So we want that type of curve, means near to what? Ideal, so that it can rectify small signal. I think not this concept is clear. What is the small signal and what is the large signal? Now, how is it possible to get this type of curve? Because for practical circuit, we are getting this type of curve. How is it possible to get this type of curve, that is the V0 versus Vs with practical diodes? Now you have to use what? Active device, that is operational amplifier. So first of all, we have discussed half-wave rectifier, full-wave rectifier. Again, here again we will design what? Precision half-wave rectifier, precision full-wave rectifier by using operational amplifier. Okay. Now, so all the new students, you can watch my session on what? Operational amplifier. I have discussed what is the operational amplifier, virtual short concept, virtual ground process, inverting OpAmp, non-inverting OpAmp. So just I am giving you the very basic things. This is the operational amplifier. This is negative terminal, positive terminal, inverting, non-inverting terminal. Here we are giving the supply, Vset, minus Vset, plus 15 and minus 15, and then this is the operational amplifier, guys, inverting and non-inverting terminal. Then watch this. Here we are giving the negative feedback, and the gain of the operational amplifier is very high. This is called the gain, open loop gain. That is nearly equal to 10 to the power 6. Input resistance is ideally it is what? Infinite, and output resistance is what? 0. And we are using one concept that is called virtual short concept. What is the virtual short concept? Vp is equal to what? Vn. Negative terminal is equal to what? Positive terminal, and that is called virtual short concept under ideal condition. Virtual short concept for ideal operational amplifier. And that is the inverting operational amplifier. For inverting operational amplifier, the gain is, that is called closed loop gain, is V0 by Vn, or this is the minus Rf by R1. Minus Rf by R1. Minus Rf by R1. Okay. Then what is the non-inverting operational amplifier? In case of non-inverting operational amplifier, we are giving input to inverting terminal. This is ground, and we are giving input to this terminal. And what will be the gain? 1 plus Rf by R1. 1 plus Rf by R1. So already I have discussed, that is the inverting OpAmp, non-inverting OpAmp. So inverting OpAmp, non-inverting OpAmp is required, and one more thing is required, that is called inverting summer. So already I have discussed also the summer. What is the inverting summer here? Inverting summer by using the operational amplifier. Inverting summer. Yes. This is the inverting operational amplifier. This is RF, right, and so on. So you can also connect one more voltage here. This is the voltage here. Now, this is the V1, this is the V2, this is R1, this is R2, this is ground. So here two inputs are connected. So what is the output here? Minus Rf by R1, minus Rf by R1 into V1, and minus Rf by R2 into what? V2. Minus Rf by R2 into what? V2. That is the summation of these two, but with negative sign. With this negative sign. So this is actually a summer. Actually it is a summer. This is a scaling factor. You can take the minus outside that. Then we are getting the addition of these two signal with gain RF by R1. Second gain is RF by R2. So this is the inverting summer by using operational amplifier. Okay. So that is the case. Now, so this operational amplifier, it is an active device. What is the operational amplifier? It is basically an active device. We are giving the DC supply 15 and minus 15. This is the operational amplifier. The gain is very high, that is up to a 10 to the power 6. Remember, we are going to use this gain. Okay, 10 to the power 6. Input resistance is very high, almost infinity, and that's why what is the current enter into the operational amplifier? 0. The current enter into the operational amplifier is 0, and virtual short concept means this terminal voltage is equal to what? This terminal voltage, Vp is equal to Vn. Virtual short and virtual ground process we are going to use here. And two most important operational amplifier is what? One is what? Inverting OpAmp. This is the non-inverting OpAmp. This is the called non-inverting OpAmp. Non-inverting means what is the phase shift of the gain? 0 degree. And gain is 1 plus RF by R1. And inverting operational amplifier, here we are giving the input and gain is minus RF by R1. Inverting OpAmp. Right? Now, so fast conclusion here. First of all, we have dealt with what? It's normal half-wave rectifier. So normal half-wave rectifier, in case normal means passive half-wave rectifier, if you are giving large signal, for example, large means 10 sine of omega t. So what is the highest value? 10 volt. Then we can assume let the diode is ideal. Let a diode is ideal. For positive half, diode is on. For negative half, diode is off. And you will get this type of output. What is the DC value of the output? 10 by pi, and that will be the answer in volt. Okay, that is the answer under ideal condition. No problem. Then why we are considering the ideal diode? Because what is the highest value? 10 volt. That is very high as compared to 0.7 volt, and that's why we can say for positive half diode is on, for negative half diode is off, because the what is the cut-in voltage required? Very low. But if you are giving the same signal, it is in the range of what? Millivolt, guys. And if you are going to consider the ideal diode, remember what is the highest value of the input? Only 10 millivolt. For 10 millivolt, it is less than 0.7 volt, and that's why the diode will remain off for full cycle of input. For full cycle of input, the diode will remain off because that signal is very small. What is the highest value? 10 millivolt only. Diode will never conduct. So diode will never conduct. So what will be the output? Output is 0. Output is 0. Because diode will not conduct. What is the current through the RL? 0, and that's why what is the DC value of the output? Not 10 by pi, it is 0 volt. So guys, when we are giving the small signal, always remember diode will be what? Practical. Diode will be practical. Okay. So when we are considering the practical diode, then how we can rectify this? It is not possible to rectify signal like what? 10 sine of omega t millivolt. So we can't rectify a small signal by using this passive rectifier. So what is the characteristics of the ideal? This one. What is the characteristics of the practical? This type. Practical circuit. So not possible. So how we can rectify the small signal? By using the precision rectifier, where the curve V0 versus Vi will start from 0 like this, so that we can get the output for millivolt. Yes, it is start. We are getting the output from the range of what? Millivolt. In this case, it is not possible. The output will start after what? 0.7 volt. So this is the practical circuit. Practical circuit here. We are considering the practical diode, and what should be the characteristics? This type. How we are going to get? Now I am going to discuss. Okay. So what is the use of the precision rectifier? Just to rectify small signal. Now, for this, operational amplifier is required and OpAmp is a active device. So already we have discussed in chapter operational amplifier and its application. This is the inverting OpAmp and that is the non-inverting operational amplifier, and this is called inverting summer. So we have to use three: inverting OpAmp, non-inverting OpAmp and inverting summer. Okay. So this is a basic concept of what? Precision rectifier. So this is the concept of precision rectifier. Now guys, watch this. Precision rectifier combine diodes and OpAmp to implement a variety of rectifier circuit with precise characteristics. It is a special class of wave shaping circuit. Wave shaping means what? We are giving the shape to the wave. For example, it is a sinusoidal waveform. We are converting into what? Unidirectional waveform. Half wave or what? Full wave. It will shape the wave like this. Half wave and full wave, guys. Okay. It is a special class of wave shaping circuit. Now, what is the precision rectifier? So, one by one I am going to discuss here. First of all, then at the end you will get the answer for all your questions. First, just watch this circuit. This is operational amplifier. This is operational amplifier. Now, I am giving this type of input. This is the feedback and this is the Vs. Okay, it is nothing but what? Voltage follower. What is this? Voltage follower. Yes. Why voltage follower? Because here it is the ideal OpAmp. You can apply the virtual short concept. So according to virtual short concept, Vp is equal to Vn. That means what? Vn is V0 and Vp is Vs. You can say V0 is equal to Vs. Output is exactly replica of the input. When the output is exactly replica of the input, means what is the closed loop gain? 1. What is the closed loop gain? 1. Right. If the closed loop gain is 1, means output voltage is exactly replica of the input voltage. Okay, that is called voltage follower. If suppose you are giving the sinusoidal signal, for positive half we are getting the positive, for negative half we are giving the negative, and so on, like this. Exactly replica of the input. Is it a rectified version? Yes, tell me. Is it a rectified version? Right? Tell me. Yes. That is the inverting summer. Now, is it a rectified version? No. It is just replica. Output is exactly the replica of the input. If you want the rectification, means what? If you want the rectification, then for positive half there will be the output, for negative half there should be no output. You have to block this. So how it is possible? How it is possible then? Then first of all, it is a voltage follower. Try to understand the concept of the voltage follower here. If it is a voltage follower, then let RL is connected here. Let the RL is connected here. Right. If the RL is connected here, R0, AVVI, R0, AVVI. Now tell me here, because of 0 degree phase shift, if it is positive half, Vs is equal to positive half, 0, positive. So what is the voltage here? Positive. Why? Because there is 0 degree phase shift. So positive will remain positive, and because of this positive, the direction of the current is downward. And yes, the output is exactly replica of the input. Then what is the role of the operational amplifier here? The operational amplifier will provide the necessary current through the RL, and it will maintain the output voltage. Simple. Similarly, for negative half, this is minus, this is plus, this is Vs. Now it is negative. Negative means less than 0. When it is less than 0, then R naught AVVI minus plus. Right? Why? Because 0 degree phase shift. This is negative, this is also negative, this is positive, this is also positive. Now what is the direction of the current? The direction of the current is opposite, like this, through RL. And again it is provided by the operational amplifier. What is the current here? 0. What is the current here? 0. So the current will be provided by the operational amplifier. So try to understand. For positive half, OpAmp will give the current in downward direction. For negative half, the current will move from ground to through RL into what? Operational amplifier. And here OpAmp, then what? RL, then ground. It will maintain the positive voltage, it will maintain the negative voltage. And that is the reason we are getting the output during positive half as well as during negative half. Now, if you want to rectify the signal, you have to block this current. For example, for positive half, I want output. Okay, no problem. It will allow the current. For negative half, I don't want output. Then stop the current. How is it possible? With the help of what? Diode. Diode is unidirectional device, and that's why, remember, when we are connecting the diode, diode will allow the current in one direction and diode will avoid the current in other direction, guys. It will not allow the current in other direction. So this is a simple operational amplifier voltage follower. Now, so this is a voltage follower. Remember, this is the diagram. It is a voltage follower, and for voltage follower, whether it is a positive half or negative half, we are getting the current, and that is the reason. It will provide the current in both the directions, and we can maintain the output positive as well as negative. Okay. Now, these are the two diagrams with Vs greater than 0, with Vs less than 0. With Vs greater than 0, with Vs greater than 0. Now, if, for example, if you want to avoid the current in one direction, then what we can do? Just connect a diode here. Just connect a diode here. Where? This is the diode, right? Negative, positive, and here we are connecting the Vs. Now here we can connect the RL. This is the V0. Now guys, remember, we are assuming the diode ideal, okay? Sorry, we are assuming the operational amplifier ideal here, and that's why we are using the virtual short concept. So just I am going to explain this diagram, what is the role of the diode, what is how the current will maintain and so on. So just I can say, assume ideal diode, ideal OpAmp, no problem. Why you can assume the ideal OpAmp? Because the gain is very, very high, 10 to the power 6. There is a negative feedback. Virtual short concept is valid. Now, if you are writing, assume ideal diode also. Assume ideal diode. Is it correct? Is it correct here? If suppose I am going to assume the ideal diode or assume the operational amplifier, yes or no? Tell me. So okay, I can carry forward then. I will explain the diagram. I am assuming the, just for simplicity, I am assuming the operational amplifier ideal, I am assuming the diode ideal. Is it okay? Is it okay? So that I can explain the diagram. So in a previous diagram, there was no diode. That's why in both the cases, we are having the current, positive half as well as negative half. But now I am going to connect the diode and I am going to explain you what is the role of the diode. Tell me. Okay, बोलो. Now, if suppose you are assuming the ideal diode, no problem. Sorry, ideal op-amp, no problem. But if you are going to assume the ideal diode, then there is a big problem. What is the problem here? What is the problem here? Simple problem is if suppose we are assuming the ideal diode, so what about this? What is the problem with this diagram? What is the problem with this diagram? Previous diagram. You can assume the ideal diode here. If it is the ideal diode, then tell me what about the characteristics? The characteristics will start from what? 0. The characteristics will start from 0. Right? Characteristics will start from 0. Okay? And then again we can amplify the signal 10 sine of omega t in millivolt. So yes, this circuit will work. So my dear friend, we have idea that what is the drop across the diode? 0.7 volt. So we can't assume ideal here. We can assume the ideal op-amp, but we can't assume the ideal what? Diode. If suppose the diode is ideal, then yes, this circuit will work. So why we are designing the precision rectifier? Because of the practical diode. That's why always remember, in that case, in particular numerical, you can find that assume ideal diode and assume what? Assume ideal op-amp and assume what? Practical diode. In every question there will be word assume ideal op-amp and practical diode, not the ideal diode. I think not is clear. Yeah. Always remember that is what is the already I have covered the operational amplifier. So please read that point. What is the gain of the ideal op-amp? Infinite. And what is the input resistance of the ideal op-amp? Input resistance is infinite. So what is the current enter into the operational amplifier? 0. Virtual short concept is applicable. Okay. So always remember that is the wrong statement. That is the wrong statement. And what is the correct statement? Assume ideal op-amp and practical diode. And practical diode. Practical diode. Ideal op-amp and practical diode. Okay. Now, practical diode. Okay, now start procedure. First of all, remember the voltage at this point is VA. Voltage at this point is what? VA. This is the V0. This is the diode. Okay, like this is the voltage at this point is VA. This is plus V set. This is what? Minus V set. Plus V set and minus V set. Now, we are providing the negative feedback, right? Try to understand. Suppose there is no negative feedback. Suppose there is no negative feedback, what will happen? The operational amplifier will goes into saturation. Operational amplifier will goes into saturation. So what is the characteristics of the operational amplifier? Remember, the characteristics of the operational amplifier is like this. This is the plus 15 volt, this is that minus 15 volt, this is called plus Vset and minus Vset. And what is the gain of the op-amp? Very, very high, that is the 10 to the power 6. And if you are giving a very, very small input, then operational amplifier will goes into what? Saturation. Plus Vset or minus Vset here. Yeah, this is the minus Vset. This is the plus V. So if the gain is very, very high, so if simply we are giving the 15 microvolt as an input. So 15 microvolt multiplied with the 10 to the power 6 and operational amplifier will goes into what? Saturation. And if suppose you are giving the input minus 15 microvolt, it will goes to what? Minus 15 volt. So 15 microvolt is the input. What will be the output? 10 to the power 6 into that and 15 volt. If it is minus 15 microvolt, then it will become minus 15 volt. Simply operational amplifier will enter into what? Saturation. If you want to avoid the saturation, then you have to apply what? Negative feedback. When we are giving the negative feedback, there is a negative feedback, the gain of the system will reduce, and that's why we can avoid what? Saturation of the operational amplifier. Always remember, if there is a negative feedback, then there is a low chance of what? Saturation. So negative feedback we are providing to just avoid the saturation of the operational amplifier, guys. Okay, right? So this is the case. Now, to gain, what is the gain of the op-amp? 10 to the power 6, very, very high. Input resistance is very, very high. Now, 15 microvolt, minus 15 microvolt, 15 volt and minus 15 volt. That is the saturation. Just to avoid the saturation, we are giving the negative feedback. Otherwise, for very small value, op-amp will goes into saturation. Okay. Now, watch this diagram. Just I am going to explain what is the voltage follower, how this circuit will work. Now, first of all, focus on this circuit. Assume the ideal op-amp and practical diode. I am going to draw the table here. Now, first, this is Vi. This is Va. What about the diode? Right? And what is the V0? This table is very, very important one. Now, guys, first during positive half, try to understand. This is a practical diode. This practical diode, initially it is off. Initially the diode is off. When the diode is off, there is no diode. When there is no diode, this loop is open. When this loop is open, just we are giving the positive half. We are increasing the voltage. Operational amplifier is open. The gain is very, very high. What is the gain? 10 to the power 6. We are increasing the voltage in the range of what? Microvolt. But what is the VA? VA will also increase. It is in the range of what? Volt. We are giving 1 microvolt here. Here it is increased by what? 1 microvolt. What is the VA? VA will become 1.1. Sorry. The gain is 10 to the power 6. It is increased by 0.1 microvolt. It is increased by what? 0.1 volt. But the diode required what? 0.7 volt. Then we are increasing up to 0.3 microvolt. It will become 0.3 volt. Then we are increasing 0.6 microvolt. It will become 0.6 volt. And finally, when it will become 0.7 microvolt, it will become 0.7 volt. So my dear friends, we are increasing the input in the range of microvolt. But what about the output of the op-amp at this point? Increases in the range of what? Volt. Means it is moving towards what? Saturation. It is moving towards which saturation? Plus V set. Why? Because it is a positive and it is a non-inverting op-amp. It is moving towards what? Plus V set. Why? Because there is no negative feedback. Loop is open. But when it reaches up to what? 0.7 volt, then the diode will get the sufficient voltage and diode will conduct. Diode become on. Once the diode become on, there is negative feedback and it will avoid saturation. Which saturation? Positive saturation. The diode will avoid positive saturation of the operational amplifier. Once the diode is on, guys, now there is a feedback, negative feedback. Watch this table. Now the loop is closed. It behaves like what? Just voltage follower. Why? Virtual short concept is valid. Therefore, Vp is equal to Vn is equal to what? V0, and therefore V0 will become what? Vs. Virtual short concept, because there is a negative feedback. So what is the conclusion here? The diode will avoid negative feedback. Sorry, diode will avoid positive saturation when input is negative, when input is positive. When input is positive. What is about the input here? Positive, greater than 0. So it will avoid the positive saturation. How it will avoid the positive saturation? Because of what? Negative feedback. Because of negative feedback. Now, positive saturation it will avoid. Then plus V set on. What is the V0? V0 is exactly equal to what? Vs. So here, how much voltage is required? Only 0.7 microvolt is required. Only the 0.7 microvolt of the input is required to just make the diode forward bias. Or in the previous case, how much voltage is required? 0.7 volt. And that's why it is not possible in the case of what? Passive rectifier. But here it is possible. Input will give only the 0.7 microvolt. Because of this 10 to the power 6, it will become what? 0.7 volt and diode will conduct. There is a negative feedback. Virtual short concept is applicable. Vp is equal to Vn and that's why the V0 is equal to Vs. And we are getting the output. And that is the first case. What is the second case? Second case here, when the input is less than 0. Not right on. Is it clear? Is it clear? I think this table is clear. First, Vp is equal to, first of all, we are increasing the voltage. Initially, the loop is open. It is moving towards the saturation. Then when it reaches toward 0.7 volt, for 0.7 microvolt of the input, diode will conduct. There is a negative feedback. Because of the negative feedback, saturation of the op-amp avoided. That is positive saturation avoided when the input is positive. And virtual short concept, V0 is equal to what? Vs. Now, Okay then. So yes, now in the second half what will happen when we are giving negative value here? When we are going to give the negative value here, then remember, watch this. It is less than 0. When it is less than 0, negative, it is moving towards what? Minus V set. When it is moving towards the minus V set, what about the diode? Diode will remain off. When the diode will remain off, it is moving towards minus V set. Minus V set. Diode is off. When the diode is off, there is no negative feedback. If there is no negative feedback, right, virtual short concept is not valid. And what is the current here? 0, because the OpAmp will not allow the current in this direction. What is the current through the RL? 0, same current. And that's why what is the output? 0. Output is also 0. So in the second case, we are getting the output 0. Now, for positive half, we are getting the output, and for negative half, we are not getting any output. Yes, this is visible here. For positive half, we are getting the output. For negative half, we are not getting the output. Means it is what? Half-wave rectifier. It is a half-wave rectifier, and that is because of what? Diode. That is because of the diode. Right? So this is a, when there is a negative feedback, always remember that there is a, when the diode is on, there is a negative feedback. When the diode is off, there is no negative feedback. Diode is off. Diode is off. Therefore, there is no negative feedback. When the diode is on, there is a negative feedback. When there is no negative feedback, OpAmp will goes into saturation. Which saturation? Negative saturation. So finally, what is the voltage at this point? Finally, the voltage will become minus V set. What about the diode? Diode will remain off. What about the output? Output is 0. Output is 0. That is the case. Now, what is the waveform for this waveform? What will be the waveform? Now watch this. What is the waveform here? 1 minute. Waveform. Now this is the sinusoidal waveform. Right now, for positive half, we are getting the positive half. For negative half, we are getting the 0 for this. So this is the Vm, 0, minus Vm, and we are getting this one. And this is in the range of what? Millivolt. This is in the range of millivolt. Now, what is the voltage required just to make the diode forward bias? The voltage required just to make the forward bias to VA required is what? 0.7 volt. Just to maintain the VA 0.7 volt, what is the input required? Input required is 0.7 divided by 10 to the power 6, means only 0.7 microvolt. Negligible input is required. From millivolt, if you want 0.7 microvolt, negligible. And that's why when we are drawing the transfer curve, V naught versus Vi, watch this. Transfer curve, V naught versus Vi, then we are getting this type of curve. So it is almost start from what? 0, but you can zoom it. It is what? 0.7 microvolt, but it is negligible as compared to what? 10 millivolt. And that's why we can say it will start from almost 0, and that is the transfer curve for precision rectifier, and this is the rectifier, precision rectifier, and that is the use of operational amplifier. Operational amplifier will increase or amplify the 0.7 microvolt up to what? 0.7 volt, and diode will become forward biased, guys, and we are getting almost this type of characteristics or this type of output. Now watch this. Now you can ask diode, what is your feeling here? You can ask the diode, what is your feeling? So diode is what? Okay, I am happy. Why happy? Because now what about the diode? Diode is on for how much voltage? 0.7 microvolt. Only for 0.7 microvolt that input will make the diode forward bias, and we are getting the rectified signal. So all are happy. When all are happy means, what about this circuit? For input, this circuit is just like what? Superhero. Superhero. Why? Because of this circuit, because of this active element, this diode is on only for what? 0.7 microvolt, and that's why it is called what? Super diode. What is the name of this circuit? Super diode circuit. Super diode. Super diode circuit. Super diode means active diode. Just we are connecting the active device in front of the diode, and it will amplify the signal. It will make the diode forward bias. And that is the super diode or active rectifier. So only the 0.7 volt is required. Now there are two more questions on this. What is the name of this circuit? That is the active rectifier. What is the name of this super diode, and so on. Two more important things is required here. First, when the diode is on, what is the voltage at VA? When the diode is on, what is the voltage at VA? For example, this is the diagram. When the diode is on, what is the voltage at this point VA? What is the voltage at this point VA? Now, voltage at point VA is, this is an important objective question. 1 minute. For example, this is the diode. This is plus minus 0.7 volt. This is Vs for positive half. That diode is on. What is the drop across the diode? 0.7 volt, and voltage at this point is Va. Now here it is a RL, and output is equal to what? Vs. Now what is the Va? 0.7 plus what? V0. What is the value of the Va? This is the drop across the diode, 0.7 plus what is the voltage at this point with respect to ground? Vs. V0, and V0 is nothing but Vs. 0.7 volt plus Vs. That is the exact answer. But what is the range of the Vs? It is in the range of millivolt. What is this? Volt. That's why this signal is very small, and you can say what is the drop, what is the voltage at this point? Only 0.7 volt. When the diode is on, what is the voltage at that point? Only 0.7 volt. Okay. Now, because we can, exact answer is 0.7 plus input, but what is the average value? 0.7 volt. Now, it is everything is fine. Is there any problem with this circuit? Yes. What is the problem with this circuit? PIV. Peak inverse voltage. The voltage appearing across the diode when the diode is reverse bias, guys. So finally we will calculate the PIV. How we are going to calculate the PIV here? Now watch. When it is negative, the voltage at this point is also negative. Voltage at this point is also negative, and when the diode is off, diode is what? Off. When Vs is less than 0, Va is less than 0, diode is off. then we can calculate the PIV. Why? PIV means maximum voltage appearing across the diode when the diode is reverse biased. Now, for example, there is no negative, because the diode is off, there is no negative feedback. When there is no negative feedback, operational amplifier will goes into saturation. When operational amplifier will goes into the saturation, so what is the voltage here? For example, it is plus Vset, it is minus Vset. The voltage at this point will become minus Vset, negative saturation. It will goes into the negative saturation. For example, it is minus 15 volt. At that point, at that time, what is the output voltage? 0. What is the output voltage? 0. Why 0? Because there is no current. There is no current. Diode is off. So on the negative side of the diode, output voltage is 0. On the positive side of the diode, output voltage is what? 15 volt or minus 15 volt. So tell me guys, this diode is reverse biased by, 15 volt. So therefore the PIV is nothing but Vset, 15 volt. This is a very, very high PIV. Very, very high PIV. We are rectifying the signal in the range of millivolt and we are getting the PIV in the range of what? Volt. And as you know, we are selecting diode on the basis of PIV rating. We are selecting on the basis of PIV rating. Is it clear? So what is the problem with this circuit? The PIV is very, very high. Why the PIV is very, very high? Because during negative half, operational amplifier will goes into saturation. And that saturated voltage will reverse bias the diode, and that's why we are getting very, very high voltage across the diode. That's why the PIV is very, very high for this particular circuit, guys. If there is any doubt? Any doubt in this circuit, then yes, you can ask. So this is the PIV. So now conclusion. Always remember, this is a super diode, just a very basic circuit. Voltage follower we are using. Then voltage follower, we are giving the current, it will pass the current in both the direction for positive half as well as negative half. Then just connect a diode here. So diode will allow the current in one direction, in opposite direction it will avoid the current. So for example, during the positive half, the diode is on. When there is a diode on, there is a negative feedback. Negative feedback will avoid saturation, right? Diode will avoid positive saturation when the input is negative due to negative feedback. Due to negative feedback. Okay, diode will avoid the positive saturation when the input is positive due to negative feedback. Right now, because of the negative feedback, virtual short concept is valid. So V0 is equal to what? Vs. We are getting the exactly replica of the input. And what is the input required to make the diode forward bias? Only 0.7 microvolt is wasted just to make the diode forward bias, because the diode is practical. Then during negative half, the diode is off. It is negative, it is negative. There is no negative feedback. OpAmp will goes into saturation. This point is saturated. But what is the V0 here? 0. During negative half, there is no output. And we are getting this type of curve. For positive half, there is output. For negative half, there is no output. And that is the transfer characteristics, right? And it is just like an ideal circuit. It is the transfer characteristics for precision rectifier. so that it can rectify the signal in the range of millivolt. Then that is the diode, right? What is the problem with this circuit? When the diode is off, there is no negative feedback and op-amp will goes into saturation, and the voltage at this point will become minus 15 volt. It will make the diode reverse bias and we are getting very high PIV. That is what we set. We set means 15 volt. Remember, in PIV we are using the word inverse and we are calculating the voltage in reverse direction. Just we have to give the magnitude of that. And the diode is selected on the basis of what PIV rating. The breakdown voltage should be greater than what PIV. What is the PIV appearing across this? 15 volt. Then breakdown voltage should be greater than 15 volt. Okay, and that is very high because we want to rectify the signal in the range of millivolt and we are getting the PIV in the range of what volt. So how we can avoid, how we can reduce this PIV, and that is the next diagram. Okay. This circuit is called super diode circuit. Please make your notes just after this. You can watch the recorded session. Please make your short notes, detailed notes. This is a very important topic, guys. So we are giving the supply here. Don't be confused. Zero, and this is the VA. Okay. Okay. Is it clear? Right. Now, how we can avoid the PIV? Second diagram. How we can avoid the PIV? Okay then. Give me 1 minute. Up to this point, if you have any doubts, then yes, you can ask. Just after Just after 5 to 10 minutes break, we will start what? Next topic. So you can take break also. And if you have any doubt, then you can ask. Okay. Just 10-minute break. Hello. Now is it audible? Now so this is about this diode, and what is the problem with this circuit? PIV, very high value of the PIV. Now how we can avoid this PIV? Now next diagram. So this is the half wave precision rectifier. Actually we are using this circuit as a precision rectifier. So is it audible? Then half wave precision rectifier. I am going to explain this diagram, okay? The break is over. Very high value of. Okay then. Now watch this diagram carefully. Now here we are using the two diodes. One is here, one is here. It is called half wave super diode circuit. Assume the ideal OpAmp and practical diodes. Always remember in question this word is used. Ideal OpAmp and practical diode. For ideal OpAmp, what about the input resistance? Very, very high. What about the output resistance? What about the gain? Very, very high. Input resistance is high, means ideally it is infinite, and the gain is what? Infinite for ideal OpAmp. And for practical diode, for silicon diode, what is the minimum voltage required? 0.7 volt. 0.7 volt. Okay. Now, then for this particular circuit, first of all make proper table here. Now, here what is the input? Then VA, then diode, right? Output, and then PIV. PIV. This is the VI. VI is connected to what? Inverting terminal. There is a 180-degree phase shift. That is the diode D1. This is the diode D2. This voltage is what? VA. This voltage is VA. This is the diode. Now there are two diodes, D1 and D2. Then first case when VI is greater than 0, positive value. When the VI is positive value, because of 180-degree phase shift, that voltage will become what? Negative. Or initially both the diodes are off. Why both the diodes are off? Practical diodes. So what is the minimum voltage required here? 0.7 volt. Initially both the diodes are off. VI is greater than 0, and that's why this voltage is what? Less than 0. It is going towards what? Minus V set. It is going towards minus V set. When it is going towards minus V set, it is negative. So because of the negative value, diode D1 is off, diode D2 is off. So there are two diodes. Now, so in this table, we will connect the two diodes D1 and D2. And then what is the V0? And finally, what is the PIV? What is the PIV? Now, because this is a VA, what is the VA? Negative. Because of this negative diode, what about the diode D1? D1 is reverse bias. And because of this negative value, this diode is what? It is connected to the cathode, means negative terminal of that diode, and because of this negative value, the diode D2 will what? Forward bias. D2 will forward bias, means on. Now, once the D2 is on, then watch this diagram carefully. When D2 is on, this is on. So what is the drop across this diode? 0.7 volt. This diode is off. You can make it what? Open circuit. This diode is on. You can make it what? Open circuit. Then this is RL. Now, there is a negative feedback through diode D2. If there is a negative feedback, this negative feedback will avoid saturation. Which saturation? Negative saturation, right? So, diode D2 will avoid negative saturation when input is positive. When input is positive due to negative feedback. Right? Due to negative feedback, it will avoid the negative saturation. Right? Now, watch this. If there is a negative feedback, virtual short concept is valid. So, Vp is equal to Vn is equal to 0. This is the virtual ground process for ideal operational amplifier. This is 0, this is 0. Now, if this is 0, this voltage is 0. What is the voltage at this point? 0. So, what will be the current in this branch? So, IL is equal to I will become 0 minus 0, 0 minus 0 upon R plus RL. That is equal to what? 0. There will be no current. If there is no current, what is the V0? V0 will be 0. We are getting the V0 is equal to what? 0. So, this is the first output is 0. Okay. Now, what is the problem with this diode? The PIV was very high. So, you can calculate the PIV in that case when the diode is off. So, what is the voltage at this point across the diode D1? V0 is 0. V0 is 0. And what is the voltage at this point VA? You can calculate the VA. This is 0 plus 0.7 plus VA. 0.7 plus VA is equal to 0. So, what is the VA is equal to minus 0.7. Voltage at this point is minus 0.7. When the minus 0.7 means this diode is reverse biased by only 0.7 volt. This diode is reverse biased by only 0.7 volt. Therefore, what is the PIV for this one? PIV for this one is only 0.7 volt. Highly reduced from plus 15 volt to what? 0.7 volt only. So, the PIV for this diode is 0.7 volt only. 0.7 for D1. For diode D1, the PIV is only 0.7 volt. So, in this way, we can reduce the PIV. So, PIV will become only 0.7 volt. Okay. Then in second case, when Vi is less than 0, when the Vi is less than 0, it is negative. So, because of 180-degree phase shift, it is going towards what? Plus V set. It is going towards plus V set. When it is going towards plus V set, right? Watch this. So, what is the what? Already finally the VA at this point, the VA is what? Finally minus 0.7 volt, right? Already we have calculated VA is 0.7 volt. Now, when it is less than 0, it is going towards the positive. Because of the positive value, D1 is on, D2 is off. D1 is on, D2 is off. When this diode is on, then watch this diagram. This is RL is connected. This diode is on. What about this diode off? You can make it what? Open circuit. Now, operational amplifier will provide the current. What is the direction of the current? Watch this. Plus minus AVVI. right? This will provide the current in this direction, and diode will allow the current from positive side to negative side, right? Now what is the drop across the diode? 0.7 volt, 0.7 volt. And now because of the negative feedback, there is a negative feedback through this diode, it will avoid positive saturation. It will avoid the positive saturation. So diode D1 will avoid positive saturation when input is negative. Diode D1 will avoid the positive saturation when the input is negative. When the input is negative, okay, then input is negative, it will avoid the positive saturation. And now virtual short concept is valid. This is 0, this is 0. Vp is equal to Vn is equal to what? 0. You can apply the KVL at Vn, KCL at Vn. What is the KCL? 0 minus Vi upon R plus 0 minus V0 upon R. 0 minus Vi upon R, because of virtual short concept, this is ground, this is ground, this is 0, 0. 0 minus Vi upon R, 0 minus V0 upon R is equal to 0, and you will find that V0 is equal to what? Minus. So we are getting the minus Vi here. The output minus, not Vi, it is minus Vi. Minus Vi. So for positive half we are getting the 0, for negative half we are getting the minus Vi. Means, suppose we are giving the waveform here. So we are giving the waveform for this particular diagram. Then what is the waveform here? Watch this. There are two halves. One is positive half, one is negative half. For positive half we are getting the output 0. For positive half we are getting the output 0. And for negative half we are getting the output. And so on. So guys, it will pass only one half. It will pass only one half. 1 minute. Now is it audible? So during the positive half the output is 0. During the negative half we are getting the output. Means what is this? Is it audible now? This is a case. It is just a half-wave rectifier. It will pass the negative half, it will block the positive half. And it will invert, no doubt, it will pass the negative half as well as negative will become positive. And that's why it is called what? Inverting half-wave rectifier. Inverting a half-wave rectifier. So what type of transfer curve we will get? Transfer curve for positive half, what is the output? 0. For negative half, this is the Vi, this is the V0. For negative half, we are getting the positive output. For example, if the input is minus 3, you will get the output plus 3. So this is the transfer curve in a second quadrant. In a second quadrant, we are getting the output. Okay, so this is a half-wave rectifier, inverting half-wave rectifier. So what is the logic here? First of all, in previous diagram, what was the problem? PIV was the problem. Now watch this diagram. PIV was the problem. Now how we can solve this PIV? First, during positive half, because of 180-degree phase shift, this will become what? Minus V set. It is moving towards the minus V set. Because it is minus, this diode is on, that diode is off. If this diode is on, there is a negative feedback because of this diode. Now, when there is a negative feedback, it will avoid negative saturation. It is moving towards the negative saturation when the input is positive. So it will avoid the negative saturation because of the negative feedback. Second thing, virtual short concept is applicable because of the negative feedback. 0, 0, 0. There is no current through the R and RL. Output will become 0. Now, what was the problem? Problem was the PIV of the D1. The problem is what? PIV is very, very high. Now, the PIV, you can calculate what is the voltage at this point. 0.7. This is 0. So, what is the VA? VA will become minus 0.7. The voltage at this point is finally minus 0.7. On the one side of the diode, voltage is 0. On the other side, it is minus 0.7. Means it is reverse biased by 0.7 volt. And therefore, the PIV is only 0.7 volt only. So, in this way, we can reduce the PIV by connecting the diode D2. So, what is the basic purpose of the D2 here? Just to reduce the reverse voltage appearing across the diode D1. How? With the help of negative feedback. It will avoid the saturation of operational amplifier. Now, during negative half, when we are giving the negative voltage, because of 180-degree phase shift, you will get the positive voltage here. Once it is positive voltage, diode D1 is on, diode D2 is off. Because it is moving towards what? Plus V set. Then, this diode is off, that diode is on. Then it will avoid the, it will give the current in this direction. Yes, diode will allow the current from P side to N side. And you can watch, it is just like a inverting operational amplifier, RRVI, or you can apply the virtual short concept. This is 0, that is 0. You can apply the KCL at this point. 0 minus VI upon R, 0 minus V0 upon R. You can directly write V0 is equal to what? Minus VI. Or according to the inverting operational amplifier, minus RF by R into VI. That will become minus VI. Then, for positive half, what is the output? 0. For negative half, what is the output? Minus of VI. Means it will invert. Again, for positive half, output is 0. Then it is just like what? A half-wave rectifier. It will pass only half portion. And it will make the negative voltage into what? It will convert the negative into what? Positive. And that's why it is called inverting half-wave rectifier. Right? So this is the inverting half-wave rectifier. So for positive half, what is the output? 0. For negative half, what is the output? Minus VI. So what is the slope of this line? Minus 1. And negative will become positive. So this is the case. Then guys, finally, what was the problem with that? PIV. But in second case, this diode is reverse bias. So what is the PIV for this diode? This is a very important question. What is the PIV for the second diode? Now you can calculate the PIV for the second diode. If this diode is off, this diode is, for example, it is off. Then when this diode is off, this is the diode. This diode is off. Now watch this. What is the voltage at this point? And what is the voltage at this point? 0. So you can find the PIV here. You can find the PIV for D2. Because D2 is off. So what is the D2 here? On the positive side, the voltage is 0. This voltage is 0 VN. On the positive terminal, this voltage is 0. On the negative side, what is the value of the VA? You can calculate the VA. This is what? 0.7 volt. Plus what? V0. Plus what? V0. Normally, this is in the range of what? Millivolt. And that is what? In volt. So it is nearly equal to 0.7 volt. The voltage at this point is 0.7 volt. That is V0. This is reverse biased by what? Only 0.7 volt. So what is the PIV for the D2 also? 0.7 volt. So for both the diodes, the PIV is only 0.7 volt. Why it is not high? Because in both the cases, operational amplifier will not enter into saturation. And that's why we are getting the less PIV for both the diodes. And we are getting the output when it is negative. So that is the half-wave rectification And what is the PIV for this diode? Because when the diode is off, we are calculating the PIV. This is the nearly equal to 0.7 volt for diode D2. This is 0.7 volt for diode D1. In this way, we can reduce the PIV. Now, this is called inverting half-wave rectifier. Precision half-wave rectifier, guys. So already we have discussed the rectifier, but we have connected extra diode here D2. Why we have connected diode D2? Just to reduce the PIV, just to reduce the inverse voltage appearing across the diode. This is the basic purpose of D2. How it will avoid? Just by avoiding the saturation of operational amplifier. Basic concept. Okay. So this is a very, very important diagram, and this is nothing but half-wave precision rectifier. So practically we are using this circuit with two diodes, diode D1 and diode D2. Diode D1 and diode D2. Diode D1 and diode D2. Okay, ये हो जाएगा सर्किट. And that is the transfer characteristics, guys. V0 versus Vi. So already I have given what is the slope of that line? -1. Because in negative half output is what? Minus Vi. Minus of Vi. Minus of Vi means Y is equal to Mx plus C. So what is the X? Vi. What is the Y? V0. What is the slope? 1. -1. What is the interception? 0. We are getting this one. तो ये हो गया. दिस इज अ ट्रांसफर कैरेक्टरिस्टिक्स. सिंपल. तो टेबल इज वेरी वेरी इंपॉर्टेंट, गाइस. टेबल इज वेरी वेरी इंपॉर्टेंट. D2 will negative saturation when input is positive and due to negative feedback and so on. Table is important. Focus on the table. PIV, what will be the question? What is the purpose of D1? What is the purpose of the D2? And how it will avoid the negative saturation? How it will avoid what? Saturation of the operational amplifier, right? This type of questions in exam. So I think now you have to cover the operational amplifier, because operational amplifier have number of applications. Operational amplifier have number of applications, just like what? Precision rectifier. So this is the PIV. So PIV for first is clear. Now the PIV for the second. Okay, is any other doubt? There you go. Always remember in this half, second half, when the Vi is what? 1 minute. This is the 1 minute. What is? Yes. Now watch this. How the PIV. For example, when this diode is off, right? According to virtual short concept, this voltage is 0, this voltage is 0. And this voltage, what is the drop across this voltage? 0.7 volt. What is the voltage at this point? VA. What is the voltage at this point? VA. VA. So on the inverting terminal of the diode D2, VA, and on the non-inverting means positive terminal, voltage is 0. What is the value of VA? 0.7 plus V0. And what is the V0? Nearly equal to minus Vi, negligible. It is in the range of millivolt, it is in the range of volt. It is nearly equal to 0.7 volt. Now calculate the PIV. On the negative side, it is a 0.7 volt. On the positive side, it is 0. And that's why this diode is reverse biased by 0.7 volt only. That's why the PIV is 0.7 volt. PIV is 0.7 volt only for diode D2. Okay, always watch. This is the VP, VN, inverting terminal, non-inverting terminal, both are 0, 0. Find the voltage at this point. It is restrict up to what? 0.7 only. Because of negative feedback, what is the voltage? Finally, it is moving towards the plus, we said. But what is the final voltage at this point? Final voltage at this point is 0.7 volt. Final voltage at this point is 0.7 volt. Right? That is the case. Now it is clear. So this is a very important diagram, guys. Precision half-wave rectifier. Half-wave precision rectifier, guys. So this is a proper table. Practice it like that. What is the voltage? If it is positive, it is negative. Negative, diode D1 is off, D2 is on. There is no current through the RL. If RL is not given, no problem. You can connect RL. If this diode is off, there is no output. I mean, this D1 is responsible for what? Rectification. When it is off, output is 0. When it is on, there will be the output. And what is the purpose of the D2? Just to reduce the PIV or peak inverse voltage of diode D1. Right? That is the basic purpose. Then, second thing, transfer curve is important for this particular diagram. Transfer curve is also important for this particular diagram. Hope that concept is clear. Very easy, interesting. Yes or no? Oh, that is the use of what? Operational amplifier, and it is called what? Active rectifier. It is an active rectifier. Then, so already I have given, no doubt, 0.7 microvolt, only 0.7 microvolt is required to make the diode forward bias. But 0.7 microvolt is negligible in case of what? Millivolt. So if it is in the millivolt, again it will rectify the signal. Again it will rectify the signal. Then finally, full wave precision rectifier, guys. Full wave precision rectifier. Full wave. How we are going to design the full wave rectifier? This is a very important diagram. We are getting question from this particular diagram. So full wave rectifier, watch this circuit, only this portion. This is a half wave rectifier. Just I have discussed, just change the polarity of the diode. I will discuss this. This is a half wave rectifier, and it is followed by what? Summer. Watch this. This is a summer. RF, R2, RF, R1. This is nothing but inverting summer, and this is a half wave rectifier. So total circuit is what? Full wave rectifier. Here the input, let V in or Vs, you can write here V in or Vs. Then this is R1, that is R1, D2 and D1. And here this input is connected here, Vs. The output of the half-wave rectifier, that is represented by the V1, it is also connected to the summer. This is also connected to the summer. Then finally at this point, we are getting the full wave. So I am going to prove this like this. And actually what is the input? Sinusoidal waveform. That's why it is called full wave rectifier. Okay, so one by one, first of all I will discuss this diagram, then I will discuss the what is the role of the inverting summer. Finally we will connect these two. Okay, so focus on this diagram. Again we can get question on this diagram also. This is a half wave rectifier. So first of all, focus on the half wave rectifier, guys. So break this diagram into two parts. Break this diagram into two parts. You can cut from this point. Right? Now, summer half wave rectifier. So this is the case. Watch this diagram. Now you can also remove this one. Okay. Now you can make proper table. Now this is a very easy table, guys. Just I am writing the VA. What is the position of the diode D1 and what is the position of the diode D2? And finally what will be the V1 or V01. So what is the input? What is the VA? Diode D1, diode D2, and what is the V01 or V1? This is the V01 or V1. Now watch this. There is a 180-degree phase shift. This is the VA. Voltage at this point is called VA. When it is greater than 0, when it is positive, because of 180-degree phase shift, you will get negative here. Because it is positive, because of 180-degree phase shift, you are getting the negative here. It is going towards minus V set. It is going towards minus V set. When it is going towards minus V set, what about the diode D1? Because it is negative, diode D1 is on. Diode D1 is on, negative. And because it is negative, what is the D2? D2 is off. Now remember, when this diode is on, there is a negative feedback, and because of negative feedback, virtual short concept is valid. This diode is off, and we are getting the output. What is the V01? V01 you can write minus RF by R1 into what? Vs. This is the Vs. That is nothing but minus Vs. So during positive half we are getting the output. During the positive half we are getting the output. Because it is an inverting rectifier, we are getting the minus Vs. Now during negative half, what will happen during negative half? Because of 180-degree phase shift, it is moving towards what? Plus V set. Always remember, when there is a negative feedback, operational amplifier will not go into what? Saturation. So just it is moving towards plus V set. If it is plus, positive, what about the diode D1? D1 is off. What about the D2 on? Remember, already I have said, this is responsible for rectification. If this diode is off, what is the output? 0, because there is no current. So output is 0. Output is 0. So for this rectifier, for this particular rectifier, according to the table, okay, now Vs. When the Vs is greater than 0, what is the V0? Minus Vs. When the input is less than 0, what is the output? 0. What is the transfer curve here? Transfer curve. When the input is positive, output is negative, like this. This is the Vi. When the input is positive, output is negative. Or when the input is negative, what is the output? 0. So transfer curve will exist in which quadrant? Third quadrant. Fourth quadrant. This is the fourth quadrant. And what is the slope here? Negative. V0 is equal to minus Vs. The slope is negative. This slope is minus 1. Negative slope, and it will be in fourth quadrant. So that will be the question. If this is the diagram only, then you can draw like this table, this one. And then you can say for positive half we are getting the negative output, and for negative half we are getting the 0 output. Or you can also draw the waveform. Okay, like this. This is a half-wave rectifier. For positive half, we are getting the negative output. Or for negative half, we are getting the 0. So it is a inverting half-wave rectifier. And we are getting the half-wave, and that is a half-wave rectifier. This one, this portion. So already I have given you the transfer curve here. in a fourth quadrant, and so on. Now, inverting summer. Okay, this is clear to you. One portion of the diagram is clear to you. So this is the case, Vs diode. Always remember, when this diode is on, there will be the output, minus Rf by R1. Right, minus Rf by R1. 1 minute. Yes, this is the minus Rf by R1. Okay, no problem. Now, then summer. Summer means, watch this diagram carefully for summer. First input to the summer is what? V01. Already we have idea about the V01. This is the V01. It is connected to the summer. Second is what? Vs itself. Second is Vs itself. Vs itself. Okay. Then if this is Vs input on what is this? V01. Now you can draw here. What is the Vs? V01, and finally what will be the output? This is the Vs, sinusoidal waveform. Right? Now, this is the Vs. What is the V01? Already we have idea. For positive half, what is the output? Negative. For positive half, what is the output? Negative. And for negative half, what is the output? 0. And so on. This is the V01. Already I have given you the idea. This was the output. V01. And this is the Vs. Now, summer. Guys, this one, this is the case. This is the R2 and that is the R1. This is the Vs and this is the V01. Now, what is the value of, because of the inverting summer, output voltage will become minus Rf by R2 into what? V01 minus Rf by R1 into what? Vs. That is the output, guys. That is the output here. Okay. Then this value R1 is equal to what? This Rf is equal to R. Just designing purpose we are getting the R. This is the 0.5 R and this is again R. Now if this is 0.5 R, for example it is a 0.5 R, then write down the formula here. It will become, what is the V01? This is the R divided by 0.5 R. It will become what? 2 Vs. 2 V01. 2 V01. And this is minus R by R. Minus R by R. It will become Vs. So you can write it is nothing but minus 2 times of V01 plus Vs. 2 times of V01 plus Vs. Okay, that is the answer. This is the output of the summer. This is the output of the summer. Okay. So what is the output of the summer? Because this is according to the design 0.5 R and this is the R. So R upon 0.5 R will become what? 2 times of V01. This is the R upon this, and this will become R upon R, that is the minus Vs, because it is an inverting summer. Minus 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 you can take common. Now finally conclusion here. This is the output of the summer. This is the output of the summer during positive half. During positive half. This is Vs. Remember, this is Vs. And what is this? What is the V01? Minus of Vs. During the positive half, V01 is what? Minus of Vs. Put in this equation. Put in 1. Put in 1. When I am putting in 1, what will be the output of this? V out will become minus of, this is become minus 2 Vs plus Vs, and this is finally we will get Vs. Finally we will get Vs. Means during positive half, output is exactly replica of what? Input. Output is exactly replica of input. Right? Then during negative half, we are using the same formula here. During the negative half, what is the V01? 0. V01 is 0. Put in equation 1. So when I am putting this 0, this will become minus Vs. So during negative half, this one is 0, so we are getting the minus Vs. Minus Vs means what? 180-degree phase shift. So negative will become what? Positive. Negative will become positive. Again during positive half, Vs. Again during negative half, minus Vs. What is this? Full wave rectifier. This is converted into what? Full wave. We are getting the both the bidirectional is converted into what? Unidirectional, and that is the role of the summer. So my dear friend, what will be the objective question? What is the value of the R2 if this is R? So it is 0.5 R and it is what? R. And that's why this formula is applicable. What is the output of the summer? This is a very, very important formula. This is the output of the summer in terms of V01 and Vs. So during positive half, it is minus Vs. During negative half, it is 0. So always remember, first of all, get the output of the summer. Then use during the positive half, V01 is equal to minus Vs. Put in the 1. This is the one equation number 1. Minus 2 Vs plus Vs, you will get the Vs. During negative half, V01 is 0. It will become minus Vs. And finally, you will get the full wave. Full wave. Easy. So what is the full wave rectifier? Half wave rectifier followed with the summer. Half wave rectifier followed with the summer. Half wave rectifier followed with the summer. Finally, you can draw a transfer curve. Very easy transfer curve here. What is the transfer curve for the final output? For final output, the transfer curve this is for positive half, output is exactly replica of the input. This is the output. So this is the transfer curve. And then for negative half, when the input is negative, again the output is positive. So this is the transfer curve for precision rectifier. Transfer curve for precision rectifier, guys. So half wave rectifier followed by the summer. Okay. Just I am concluding it. First, this is a summer. This is the inverting half wave rectifier. And that is what? Summer. Inverting summer. Okay. Now you can separate these two diagrams. First of all, try to understand what is this. So you can divide it into two parts. Then in first case, it is a half-wave rectifier. Always remember, no need to find the PIV. Already we have idea how we can reduce the PIV just by avoiding the saturation. So already we have discussed. PIV is 0.7 volt for both the diodes, not more than that. 0.7 volt for this diode, 0.7 volt for this diode. Just to understand what will be the output. So during positive half, this diode is on because of 180-degree phase shift. This is negative. This diode is on. We are getting the output. And what is the output? Minus R1 by R1 into Vs. It is the minus Vs. During negative half, this is negative, this is positive. When this is positive, diode D1 is off. Always remember, once the diode D1 is off, output will be 0. This is responsible for what? Rectification. Once this diode is off, there is no current through this, and what is the current through the RL? 0. Output will be 0. Now for this, for positive half we are getting the negative, for negative half we are getting the 0. So you can also draw the transfer curve here. So this is the transfer curve for this diagram only. It will be in the fourth quadrant, first, second, third and fourth quadrant, right? Then summer means the output input to the summer is, first input to the summer is what? V1. V1 means output of this diagram, V01. And what is the V2? V2 is nothing but Vs, same input. So you know the idea about the summer. What will be the output of the summer? Rf by R1 into Vs, Rf by R2 into V01. So what is the minus Rf by R2 into V01? So R2, what is the R2? 0.5 R. So point R divided by 0.5 R will become 2. R by R will become minus V. So minus this is the output of the summer equation number 1. Then now you have, this is the Vs, this is the V01, positive will become negative and negative it is 0. Then finally watch these two things. What is the input? Input will remain same, Vs. Vs is Vs, input. Then but during positive half, what is the V01? It is not Vs, it is minus Vs. To put in this equation, when I am putting in the summer, it will become minus 2Vs plus Vs. So I can write the formula for the summer here. Summer, what is the output of the summer? V out is equal to minus of 2V01 plus Vs. Right? It is the equation number 1. Minus of 2V01 plus Vs. This is the output of the summer. Oh, I have to write here. Plus Vs. Okay. So first, when I am putting this value during positive half, what is input will remain input. What is this? Minus of Vs. So put here minus of 2Vs plus Vs, it will become minus, this is the Vs. Minus minus, it will become plus Vs. Okay. In the second half, during the negative half, what is the V01? 0. To put the V01 0, it will become minus Vs. Finished. The negative portion will become positive. You will get the answer in terms of what? Input. No. If suppose we are getting the reverse negative half, then we are getting the same input. So we want to rectify it. Now positive will remain positive, negative will become positive. And that's why we have used the summer. This is the full wave. What is the meaning of the rectification? Bidirectional waveform is converted into what? Unidirectional waveform. Okay. Bidirectional waveform is converted into unidirectional waveform. That is the rectification. Easy. So this is the equation number 1. First put in 1, second condition put in 1. In first, during positive half you will get the Vs, during negative half you will get the minus Vs, and that is the output. And this is the transfer curve. Whether the input is positive or negative, output is always positive. Output means this output, final output. Guys, remember, this is the V0 one, and finally we are getting the output. So question by question we are improving. So in first question, in first diagram, we have learned about the PIV. What is the PIV for diode D1? What is the PIV for diode D2? It will remain 0.7 volt. Don't worry about that. Already we have discussed. It will avoid the saturation of the operational amplifier. Now, when we are talking about what full wave rectifier, just focus on the what is the role of the summer. What is the role of the summer? Now it is clear. Yes, reverse waveform means during the negative half. In negative half, we are getting the minus Vs. What is the role of the minus Vs? This is the minus, means this is Vs. What is the meaning of the Vs? Input, it is a plus 5. What is the value of the Vs here? Plus 5. What is the value of the Vs here? Minus 5. So when I am saying that it is minus of Vs, means minus 5 will become what? Plus 5. It is complete Vs. Complete Vs. Here, what is the value of instantaneous value of the Vs? Plus 5. What is the instantaneous value of Vs? Minus 5. It is Vs. When I am saying that it is minus Vs, means the negative will become what? Positive. Or during positive half, it is equal to Vs. So positive will remain positive. Now it is clear. Right? Input is input. It may be positive, it may be negative. It may be positive or it may be negative. Just generalized term Vs. No, you can't say it is always remain Vs. It is a completely Vs, whether it is negative or positive. In positive half, output is equal to Vs. In negative half, output is equal to minus Vs, and that's why it is reversed. Minus 5 will become plus 5. Okay, always remember when we are writing Vs, it is a general term. So here it is a Vs, here it is equal to minus Vs, here it is a Vs. Vs means what? Watch this. Okay. Vs is a complete waveform, input waveform. Right? Now, in terms of Vs, what is the V0 one? Tell me. In terms of Vs, what is the V0 one? Plus Vs or minus Vs? In positive half, the V0 one is minus Vs. Minus Vs means it is plus 5, but what is the V0 one? Minus 5. And during the negative half, what is the value? 0. Now watch this and compare this. What is the V out? Here it is equal to plus Vs. What is the? It is negative, but it is positive. So what is this? Minus Vs. Okay. Watch this. What is this line? What about this line? X-axis. This is the complete Vs. No doubt. The value of Vs is positive here. What is the value of Vs here? Negative here. But on x-axis we are representing the Vs and y-axis we are representing the V0. What about the V0? V0 is positive here, V0 is negative here, but line represent V0 only. Instantaneous values are different. It may be positive or it may be negative. Okay. Okay then. So always focus on this. This is already I have discussed the full wave rectifier, half wave rectifier. Then question. I think now up to this point everything is clear. Now guys, assignment for you. And I will solve. I think tomorrow or day after tomorrow we will arrange one session, numerical session every time on you, right? So please watch that. The question answer on what this rectifier. This is application of diode. Complete questions session on this topic. right? This is the first assignment. This is a precision rectifier, the transfer characteristics for the precision rectifier circuit shown below. Assume ideal op-amp, and what is written here? Assume ideal op-amp and practical diode. So don't worry about that because we are using the practical diode. 1 R is connected here, 4 R is connected here, 20 volt is connected here, diode D1, diode D2, V0 is connected here. Okay, then this circuit transfer karo A, B, C or what D. It is -5, -10, this is +10, -5, -10, it is +5. Then this is the +5, this is the +5. So from this question you will get multiple concept here. So first of all revise, right? First of all revise it and then try to solve it. This is the assignment for you. Right, this is assignment for you. So watch the schedule, right? Suppose tomorrow it is possible, then I will arrange one session on then YouTube at evening. So please try to solve all these questions. This is another question, the transfer characteristics of the operational amplifier circuit shown in the figure. So I think it is visible to you. This is a half-wave rectifier, right? Already I have discussed. And what is this? Inverting operational amplifier. So half-wave rectifier followed with the inverting operational amplifier, then which characteristics is correct? Second assignment in 2014, electrical branch. 2014, that is the precision rectifier. Now, but that word precision rectifier is not used here. Precision rectifier is not used here. Right now, you can just after the class message me on WhatsApp. Then watch this. Again, this is a very good question. It is a MCQ, but consider the following circuit. What is the function of diode D2 in the above circuit? In engineering services exam, this is an objective question, MCQ, but you can make it what? MSQ also. But what is the best answer? You have to find the best answer. If it is MCQ, only one answer is correct. So what is the best answer? You please read all the points, read the theory, right? And then I will discuss. It is a third assignment. Then fourth one, this was the question from instrumentation branch, instrumentation engineering in 2007. In the circuit shown below, the switch S is closed whenever the input voltage is positive and open otherwise. The circuit is. So this is the OpAmp, first one and second one. So this is assignment. This is the third assignment for you. Okay. Now, to try to solve all these questions, guys. So we will discuss more question. So this is my Telegram channel. You can join. And then thank you for attending the session. Thank you very much. Okay. So hope you have got the idea about what precision rectifier. This is important topic for all competitive exams, whether it is GATE exam or what engineering services or other competitive exams, ISRO, DRDO, BARC, right, AEJE. So that in AEJE that they will give you the diagram. What is the name of this diagram? Simple question. But in a GATE exam, different types of question, numerical based question. Okay. Okay then. Thank you. Please make your notes, detailed notes, short notes, right? If you find any difficulty, then please simply write in comments box. I will arrange more session on this. Okay then. Thank you.